This is a prototype for TVT Integrated Microcontroller with Wi-Fi and multifunction radio frequency remote. We feature an STM32 ARM Cortex M3 microcontroller with 1 MB of flash, 128 KB of RAM memory, and our processor is operating at 120 MHz with the capability of 8 digital and 6 analog programmable input or outputs. Our circuit board features 4 Form C relays rated each at a maximum of 10 amps at 230 volts. Presently, we're using one relay for the up run command. We're using the second relay for the down run command. The third relay for safety interlock circuit to energize solenoids at certain doors or access points. And the fourth is for a remote controlled light circuit. Our RF with signal width has a range of a maximum of 750 unobstructed line of sight, 750 feet. Our device has the possibility to be programmed, serviced, monitored, and operated through secure 2.4 GHz 802.11b, G, or N network to the internet by internet and can be operated, monitored, programmed, or serviced through any internet-enabled device in the world. Our test platform consists of a single to 3-phase VFD operating a 1.8 kilowatt TVT motor coupled to a 400-to-1 gear reducer. The inputs for up and down are coupled to board relays in 1 and 2, as already mentioned. This is our RF board. On our test platform, we're utilizing normally open magnetic reed switches. In position 1, we have, and 2, we have 2 reed switches wired in series to afford a D-cell trigger and home location trigger. Position 2 has 3 reed switches wired in series to afford D-cell trigger on each side of the move, as well as a home location trigger. In practice, the limit cam or magnetic strip employed would eliminate the need for more than one switch per person. In this case, we're using just a small magnet, so if the limit cam was this wide, it would be able to trigger here, continue it closed, and stop, showing the home position is here. The limit switch or complete low voltage signal back to our control board and is read constantly by our microcontroller. The RF board similarly communicates with our microcontroller. The safety circuit is also connected to the microcontroller, is being checked constantly every so many milliseconds. From the position 1, which is what we're at now, pressing the 1 button has no effect. So what's being read by the radio frequency board, as you can see, is the microcontroller is not taking action because it sees that the device is in the 1 position. Pressing either the second floor or third floor or second or third position, the microcontroller will receive the signal and take action by closing the run and the safety interlock relays, as seen by the LEDs right here. So the device sees on command, moves to position 2 until it sees the limit switch positions open and signal the microcontroller to stop. Similarly, if we press for the 3rd position, the drive will accelerate, reach the deceleration point, and stop, energizing the same safety interlock relay and forward run or up run relay. To return to the second position or first position requires only the pressing of these buttons. Similarly, the microcontroller reads, if you were to command to go to third position, it will receive the signal, process, and realize that you're at the third position right now. If it was moved like this, we went to the third position, it will complete. Now, in the motion command, we're able to, let's see, return to the first floor, or first position. We can stop with the all stop command. With the all stop command, the safety interlock remains closed, but the run forward or run reverse relay is open. The device waits for a return command. In this case, could be the third or at the second floor. So we'd have to go back to the second position. We'd have to go to the first. The fourth position on the remote we're using for the fourth relay, which allows us to energize a security light. And with 10 amps, 230 volts maximum, we have plenty of power for to afford an LED light or a stronger light of over 1,000 watts. So it's quite a bit of power. 1,000 watts at 120 volts. So we have plenty of power for that to have a nice bright light, which we can turn on and off from our remote. Stopping points can be adjusted, and the acceleration or deceleration rate can be changed on the drive. To adjust the stopping point for accuracy, if we accelerate the deceleration rate, the drive will stop sooner. If we move the limit cam away, the drive will stop here, or further out with the same deceleration rate, or if we move it closer, it'll pass. So this is easily adjusted in the field one time, and then you'll reach the same stopping point regardless of the load that's being applied. The prototype shown fits inside of the cover of our 1.5 horse VFD, single to three phase, 230 volts. And the prototype shown will be reduced inside what's made production ready and will be powered off of the VFD completely. This is the TVT Integrated Microcontroller with Wi-Fi and multifunction radio frequency remote from TVT America.